the data, from my understanding, is not really structural data, right? So we have the drawings, we have reports, we have the models, but how can we convert this kind of unstructured data to a structured data, which the machine, they can be readable for them? That's the biggest challenge. And OpenBIM, the open file format, I guess, is probably a solution. So this means, once we got the different models in the open data format, I think there must be a potential that we can use this kind of the structured data to train our deep learning models. And after that, we can kind of really unlock the AI potentials.
Hi, Yatong. How are you today?
Good, thanks. How are you, Andrea?
Very, very good. I'm very excited to have you here today on the podcast. And today we are going to talk about digital engineering in construction with Dr. Yatong Nie. She currently works as a digital engineering coordinator at GAMUDA, but previously she had similar roles at WSP and in other similar companies. But we're going to share her career path and how digital engineering can improve processes for the construction industry. But before we start, I have a couple of icebreakers for Yatong. Is that okay with you, Yatong?
Yes, that's perfect.
Amazing. So if you could have any skills or ability, could be real, could be fictional, what would that be?
Yeah, that's a very interesting question. I guess I always want to have an anywhere door. That is kind of a small tool in the Doraemon, that cartoon. I don't know if you have watched that before.
I love it. Yeah, I love it.
Yes, I really love it. It's like, it basically can bring you to anywhere in the world just by thinking of the destination. Because for me, I always think, my leave is not enough every year. But I spend lots of time on the flight. If I want to go back, because I'm from China, so if I want to go back to China, so I probably will spend half day or the full day on the plane. That takes me too much time. So I think, if I get this anywhere door, I can just go anywhere for holidays, if I want. So that's really cool.
Yeah, I agree. I would love to have that. I'm originally from Italy, as people can tell probably from my accent. And if I have a skill at that, I could maybe shave 24 hours of travel every time
yes,
I have to go,
sure.
to go and see my family. That's great. And if you think about your career, you may have spoken with many people, you may have many different mentors, but what is the best piece of advice you've ever received in your career?
I think I remember a very recent one I just got from my mentor in my project and one project. So I think his perspective is very different for me because he's kind of, the technical director for the whole project. So what he told me is like, we should always find the critical aspect of a project. So for the project, I guess our understanding is the programming is always the first important critical aspect, and also safety, environment, and quality. They are all the kind of the important aspects of the project. So that's where we should, whatever we do, the digital engineering, the design team, construction team, everyone should be kind of put their efforts on these critical aspects.
Yeah, and that I can't agree more with that. It's very important. We always have to think about safety, environment, and I agree 100%. And if you think about your career, can you start telling us a bit of your career journey for people who are not as familiar about your story and what led you to work in the digital space for the construction industry? So why are you here doing this today?
Yeah, thank you. I think my journey for the digital space, the digital industry, all kind of started when I was doing my PhD back in 2018. I think during that time, that's when the AI started to be very popular. And everyone kind of, talk about AI. Even though I'm doing research, I can hear, people doing the research by using AI quite often. And AI, I think, is doing, even until now, it's kind of the annual keyword for every year. like the most popular keyword. So that makes me think of like why AI is that much powerful and how we can bridge the gap between the civil engineering, which is a kind of like relatively traditional industry, with this AI, the deep learning, machine learning, this new emerging high technology industry. And then after I graduated from my PhD, I joined a small design consulting firm, which is the Digitize Consulting. So that's the first time I got some hands-on experience on the digital engineering industry. So back then, I worked on some of the major infrastructure projects in New South Wales, like the M5, M6, and also some like mainly the road projects. And then that was the first time I got to know about the IFC, BCF, this kind of the open formats. It also gives me some chance to write some of the scripts to automate the workflows, make the process more efficient. That's kind of make me, excited. I said, oh yeah, I can do pretty much lots of things in the digital world. And then I moved to WSP, still kind of focused on the digital engineering, and I was working on some of the train station upgrade projects. And also I was working on the One Victoria project, which is the South Geelong to Warm Pond railway duplication. In that project, I kind of got to know, how to set up a more efficient and easy to use digital workflow to help the coordination and collaboration between the design team and construction team. And now at GAMUDA, I'm looking after the M1 Pacific Motorway extension project and also some of the other small tender projects. So this is kind of the first time I work on the construction company. So it's totally different side. And it gives me very different perspectives on how the models and the data can directly impact on-site operations. So I started to think more and put more focus on how we can use the models data to bring the practical values to the construction team, what our construction team really need and how we can help them and how we can make the construction more efficient. And I have to say, like my experience in GAMUDA is quite challenging at the beginning because it's a totally different world, but it's a really rewarding experience, and I do enjoy this.
Thank you very much for the introduction. I can see how your career has evolved between consulting and the company that actually build the stuff that the consultants design. So it's very interesting to to understand your point of view and see what you have learned during your career journey, because maybe this problem can be solved in slightly different ways from different point of views. And yes, I'm very keen to learn about that today. And maybe let's start simple and let's start thinking about the actual word digital engineering and what that means, because I'm not sure we all agree on what that means. So I'm very, very keen to understand, what does engineering mean for you in the context of the modern construction?
Yes. I think the digital engineering, everyone must have a very different understanding of DE. But for me, I guess the biggest part is definitely the 3D models. That's the most popular concept in DE, I guess. But it's not only just about 3D models. It covers much more broader concept. For me, it also covers data, the automation, and the visualization. So it's more about how we can integrate all of this DE component into the every phase of a project. So it can connect the design, construction, and operation maintenance through the digital workflows. And I think the key spirit of DE is try to ensure the information is all accurate, accessible, and actionable for all the project team members. And also, I guess, another spirit I really like is we all want to work smarter, not work harder. So there is always a better way that can make us work smarter.
Yeah, no, that's great. Like I myself experienced the transition to digital engineering and how that evolved over time. And there was a period of, I would say, from my point of view, strong ambiguity. It wasn't entirely clear what this discipline was supposed to do. And now I can see how the discipline is evolving and becoming more and more clear. And that is also helping the reputation of this discipline and how this is changing the world of construction. Now, one of the outputs of the digital engineering as a discipline are the digital tools. And they're probably changing the way construction companies operate. So, but from your point of view, how are these digital tools changing how the construction companies operate on the everyday tasks?
Yeah, I think it does change a lot. It's kind of transformed the way, I guess probably two big aspects. The first one is it transformed the way that how the different teams collaborate with each other. And the second big one is how we make the decisions based on the data instead of, some older like reports things. So for the first one, in the past, I guess most of the construction team, they used to heavily rely on the paper drawings, but it's kind of very hard. Like when you have the paper drawings printed, it's hard to confirm if this is the latest version or, I'm using the old version. Probably different people has a different version. So it's kind of hard to talk with each other. But now, because we have the CDEs and the common data environment set up, and also some of the cloud-based platform, and it helps the whole project team, to make sure that everyone on the project have access to the latest and the most reliable data. So this means no matter you are the engineers, the project managers, construction team, the design team, everyone have access to the same data and we talk on the same page. So I think that's a perfect thing for us, when you are really running a project. And the other impact, I would say, is the decision making based on the latest data. I guess it's kind of the common practice now for many of the big construction company that we have lots of the live dashboard, which we can put the latest data from, the models, the survey, the drone survey, and GIS, these platforms. So we can track the progress. We can even forecast the cost and manage the risk in real time. And that's the biggest change I can see, I think.
Yeah, no, definitely. I agree with you. It's interesting how digital engineering has been able to benefit from a series of different factors. So some of them could be related to hardware, the introduction of new hardware technologies. People may think of drones or like physical devices that enable things like reality capture, for example, but also from the software point of view. So there has been a shift, a transformation that has supported the digital engineering discipline, which then has emerged to take advantage of these changes. Can you think of any other key benefits of digital engineering in the real world? Anything else you'd like to add?
Yes, I think still the biggest benefit for me is definitely to change the way the team can communicate and collaborate. Because now we have the digital models, right? So before, I guess, when we discuss something, during construction, everyone is talking 2D, right? So you say, but the problem of 2D is, say, if I couldn't really get the full picture of what you are talking about. Probably the image in your mind is not the same as the image in my mind. So that's the biggest issue. But now, because we have the 3D models, so we can pretty much talk the issues when we look at the 3D environment. So for example, like in M1 the project I'm working on, so we have set up the 2D and 3D model overlay features. So this means when we are reviewing the 2D drawings, we can kind of overlay these 2D drawings on a 3D environment. So we can have a full picture of, how this 2D drawing, this, cross section or the, plan view works in the 3D environment. So this means when the team discuss any of the issues, there won't be any misunderstanding, and it facilitates the better communication. And with this 3D model, another I think a very useful feature is the clash detections. We all know if it's another common practice now is we do all the clash detection before we run into the construction. So I guess we can kind of eliminate, I would say 90% of the clash issues in the design stage. And that's definitely reduced lots of the rework. And the rework is the biggest pain, I guess, in the construction as well. So that's a benefit, I guess, from the 3D model perspective. But now, not only we have the 3D, people start to talk more about 4D, 5D, or even 6D. So the 4D simulation, I guess, is another key benefit, because before the construction team really start working, they can simulate what is going to happen on site, so they can identify any of the issues, the safety risks early, and resolve them early. So I think I have put a lot of things here, but the key,
No, I agree. There is a lot going on, and it feels like now that digital engineering is improving the way people communicate on site and during the design phase, it feels like it has created a new language that enables the different parties to speak in a more efficient way, that then minimizes what, as you said, work, minimizes mistakes, which then overall leads to a better construction, and overall leads to reduced cost, which then it's an improvement for the society as overall, as an overall entity, because it will make buildings more accessible at a lower price and probably of a better quality, which is a big win. So sometimes we think about these digital tools as just like a way to improve efficiency, but I would say let's also think about the impact that can have on society and all of us, which is all of us. Now, every transformation has challenges. So we are not here to say it's all easy. We know that every single transformation will have challenges. But from your point of view, what are some of these key challenges that you see on your everyday work?
I think there are definitely some very big challenges. For me, I guess the challenge is the actual implementation, I would say, because at the moment, I guess many of the companies, the organizations, and the government, we have already done lots of the digital engineering strategy, the planning, the roadmaps, policies, but all of these things, all of these better technologies, they won't drive the change themselves unless they are implemented, right? So it's kind of the hard, the challenge is how can we turn this kind of the perfect plans into actions, and to get some of the tangible outcomes that can really make a real difference on site in the design review, in the construction decision making. I think that's how we need to shift the focus now. But I kind of understand why we have this kind of the challenge, because the first key thing is that the cost. People still, complain too much about the high cost of the softwares, the modelings, and also we have some of the constraint from the project side. So it's not an easy process, I would say, but I can see the whole industry is kind of, slowly progressing. Still promising, yes.
Yeah, no, it's nice, because if you think about any transformation, and if you align that with our lifespan, maybe 10 years could feel like a long time for us, because our life, lots of things happen in our life in 10 years, but in the big picture of the construction industry and the history of construction, like 10 years, 20 years, 50 years are like nothing. If you compare with what happened in the past, from back in the days, the Egyptians, the Roman Empire, the ancient Greece, the structures we have in Asia, in China, like we are experiencing a change that is a lot faster than all of the changes we have ever experienced before. And that, of course, creates challenges. So one of the things you just mentioned is the improved communication. I've said, yes, this is creating a new language, a new way to communicate. And I think there is an important role here for something we call OpenBIM for the construction industry. And how does this differ from traditional BIM workflows? So from your point of view, what do we mean with OpenBIM, and how does this benefit the construction companies at the moment?
Yes, this is kind of my favorite topic, I would say, for OpenBIM. Nice. Yes, but I understand this OpenBIM term probably is not very familiar for everyone, even if you are like working in the DE industry. But I would like to probably use the example of open source. I guess it's probably been a little bit more popular because, with this AI becomes more popular, probably everyone is talking about the open AI, the open source. So it's all open. I guess the open for me is, it allows everyone to access to the content. It doesn't matter if it's free or not free, but it just gives you the access and more flexibility. So I think OpenBIM kind of follow the same spirit. So it's an open standard, and it is to facilitate the collaboration and data exchange between the different formats. So let's probably think about the traditional BIM versus the OpenBIM. So the traditional BIM is normally kind of tied to a specific software ecosystem. Like now in the market, we have the Autodesk, we have the Bentley software. But the problem is this kind of the big vendors, their file format, they can't really talk with each other directly. So this caused the compatibility issues for everyone. But OpenBIM, on the other hand, they use the open format like IFC and BCF. So the open format means that different tools, different vendors, they can exchange the data directly without losing any of the critical information. So this is kind of the key difference between the traditional BIM and the OpenBIM. I guess it will be very useful for the large scale project where we have multiple disciplines involved. So for example, in the for my project, in the M1 project, it's a large road project. So we have so many different disciplines. But for the civil engineering, in especially in Australian market, we basically use 12D. It's a very dominated software. But in the structure industry, they normally use Revit or like 3D AutoCAD. So that's kind of the different file format will cause lots of the issues. And the way to resolve this kind of issue is to, have a common data standard, which is the IFC, like I guess we will talk about IFC more later on. But this kind of the common data format is a perfect thing to help us, reduce some of the conversion issues and have the better communications. And we won't miss any data, and we don't need to do extra works, to do the model federation and this kind of things. And I guess how does it benefit to the construction company is, again, it helps us to streamline the process. It doesn't matter if we are doing the model federation or if we want to kind of do some of the data extraction. We can use this kind of the open format to facilitate this streamline the process.
No, very good point. And it's been interesting to see the evolution of these platforms and digital tools that have been developed kind of independently. So different companies developing their own things, trying to resolve problems of their own industry. And they have all created something that are like products that are slightly different that can still be integrated under this IFC umbrella. So I think the results of this fragmentation is due to how these companies have evolved and developed their software to meet the market. And then once we have developed all of these products, we now have a bigger problem, which is how do we stitch everything together? And we allow everything, we allow all of these platforms to speak with each other. So now we have a new problem. And as you mentioned, this problem can be solved in a way with IFC models. And one way for me to explain what IFC models are, like to simplify that, to explain to people that don't know anything about it and maybe don't want a long explanation, has always been, think about IFC like the PDFs of the models, because it's just something that you extract and you can read it from anywhere. But from your point of view, what are these IFC files and how they can improve collaboration in BIM?
Yes. Another my favorite topic. Nice. So I guess for IFC, it's not really a file. I think it's a file format. So normally I like to use the example of the universal adapters to describe the IFC files. For me, like I travel a lot. So every time when I go to the different countries, I guess everyone has the same problem. The different countries have the different the Power Athlete standard. So this means, the device I can use in Australia, they won't fit in the one in Europe or in the US or in any other Asian countries. It's all different, right? So to solve this problem, what we can do, we can either to bring, multiple different adapters, or we need to bring lots of the chargers, which is a very frustrated process. So I hate this. And I guess that is something happens in the BIM world as well, right? Because the different vendors, the different teams are using different softwares. So if we don't have any common format, so this means the different files from the different discipline teams, they won't be able to plug in with each other smoothly. Right, this is the compatibility issues we just mentioned. So this means, we either miss some of the data or we need some of the extra work to convert the file format to be able to match each other. And I guess that's where the IFC comes in. So by using this IFC file format, no matter what software you are using, so IFC kind of makes sure the data transfer and exchange correctly. So it can keep everything consistent and reduce the errors, makes everyone's lives easier, much easier.
Yeah, makes total sense. And this OpenBIM is great, but we also have problems and challenges. And what do you think are the limitations and the challenges for OpenBIM at the moment?
I guess, yes, it has lots of the benefits. Say, it streamlines the process. It allows us to do many of the like fancy stuffs, but the biggest challenge is, I would say, is the mindset. Yes. So even for some of the people who are working in the DE industry, I don't think many of them, they see the benefit and importance of this OpenBIM format, like the IFC file format. I kind of can understand that. Say, for example, when our modelers who have been working in the building sector for like over 10 years, 20 years, they probably can only get used to use the Revit, like for this kind of the single software. So they would say, everything can be done in Revit. Why do I need the IFC file format, right? Yeah. It's just that creates more trouble for me. Why do I want to export and import the IFCs? But I guess the thing is, it benefits more broader team, not only the modelers, the drafters, but for the project engineers, the project managers, and also even our client, the government. So that's where it facilitates the collaboration and the coordination. And another challenge, I would say, is the software limitation. Because at the moment, I can see many of the authoring software, they probably won't be able to fully support the IFC export that is compliant with the Building Smart standard. I think they're improving, they're changing, but still, you got some of the minor issues from this kind of the IFC file exported from the authoring software. So yeah, that's probably will cause some other like compatibility issues as well.
Yeah, no, totally agree. And I want to change gear and talk about something that I know you're a guru, like you're a Python guru, and I would like to have a chat with you about that. And because many people may be familiar with Python, Python is a programming language, but I would like to know from your point of view how Python can be used to automate and optimize construction processes. Can you share this with us?
Yes. Yeah, there are many, like all of my favorite topics. So Python, I guess I learned Python when I was doing my PhD. I have to say it's a very, it's kind of easy to learn and easy to read programming language. It can do lots of the things, it's very popular use in the deep learning, machine learning industry. But in the construction industry, I guess, the most powerful thing I can think of is to streamline the process of everything. For example, when we are using like the 3D models, there are lots of the rich data inside the model, right? So we want to like export those data and try to, either validate this data or use some of the data to create our dashboard. And the whole process, we want them to be more efficient. And how we can achieve this is to use Python, this language, or I don't really want to limit the programming language, because there are so many other programming language that can do the same thing. But as I said, Python is quite, it's very easy to use, I think, easy to learn as well. So I'm a very big Python fan. And I think that's from the model perspective. But again, for the construction team side, I guess there are so many, documentations and reports they need to do every day. Even the simple task like upload and import file, merge the file, compile the Excel spreadsheet. These kind of the things, the documenting, the repetitive admin works, they all can be streamlined by using Python. This very magic tool, I guess. So I guess the key idea, the key spirit is to try to reduce the workload for our project team and try to allow our engineers, the construction team or everyone working on the project to focus on the execution. And also, I really highly recommend everyone to look for some of the other programming language as well. The easiest one probably, there are many visual programming language or the low code or no code platform that can do the same thing. Like I know in the if you are working on the consulting side, many of them they use Dynamo in Revit, and Grasshopper. These are all very great tools which can do lots of the efficient workflow and help with the daily task. And there's another one which is called FME, which is more widely used in the spatial, JS industry, and that can automate lots of the workflow as well. But yeah, just don't always probably limit in the Python, this single language. There are more things available on the market, and it's also like some of them they don't really need too much programming skills. You don't really need to write the code. You just drag some tools, the box, and then you can do the same thing.
Yeah, definitely. And I remember like many years ago when I started learning programming languages to improve construction workflows, if at some point it felt like magic, the ability of doing so many things with a click. That was my dream. My dream was to be able to design something with one click button that design everything for me. That was the goal I had in mind. And yeah, Python was one of the first things I started learning because, as you said, it's relatively easy to learn. And when you said that, I was thinking that probably the audience will be split in two parts. Some people will listen to that and say, okay, it's easy, I will get started. And some of them will be like, Yatong, what are you talking about? It's so hard. So yes, I think it is easy in the context of learning programming languages. But if you start, and I encourage everybody to start learning programming languages, don't give up at the beginning, because it could feel overwhelming and disarming at the beginning,
exactly.
but continue, and at some point it will feel like second nature, and you will just write Python code like you write English or whatever is your first language.
Exactly. Yes. And we can start from some like the no-code platform, like Dynamo or FME. That's more easy to learn.
Yeah, that's true. And yeah, a good way to start, I agree, would be Dynamo, Grasshopper, where you can start with these blocks that then are connected to each other. At least you start understanding what is the logical flow of programming. And then as you evolve, you will find that certain blocks of Dynamo and Grasshopper don't exactly do what you want to achieve. And this is where you start introducing your Python scripts to achieve a more specific goal that will help you get your job done in a faster way. So it's a process, and it could be very rewarding when you start learning how to use these things. But Yatong, you have experience on the structural engineering side, and can you share with us some practical use cases or example of how you have used Python in BIM from the structural point of view or in real life?
Oh yes, I guess one thing I want to talk about is Python is a programming language, right? But then the better thing, as we mentioned before, we have the OpenBIM, which is an open file format. So if we combine this kind of the two things together, I think that's where the magic happens. So the better use case at the moment, like what I did, is for the data extraction, I guess, because say for many of the models we have available on the project, there are so many data inside the models. So from the construction point of view, many of them, they would like to get the quantities from the data, right? There are multiple ways to do that. You don't have to use Python, but the beauty of the Python is it can give you the result very quick, probably just in seconds, right? So you can get the full result of the multiple, let's say 10 or 20 different IFC files from the models. So that's has changed the whole process a lot, right? It saves, I don't know how much time it can save, but it saves really a lot of them. And for the structural engineer, I guess it also has so many use cases. The easiest thing is, when you do the design, the structural design, everyone do the stress analysis, right? So by using Python, it's also very easy to get a stress analysis result. So you just need to populate, your formulas and then your input, and then click the button, then you get the result. That's the very beautiful thing. It saves lots of time, and then you can do a lot of the different parameters. Change a lot of different parameters as well. You can do the they call this sensitive analysis as well. So lots of different things you can do by using Python.
Yeah, no, very good point. And when I think about data extraction, then makes me think that the industry has evolved creating these models, and basically models are just lots and lots of data that humans cannot understand at glance anymore, because there is so much going on. Previously was a big gigantic piece of paper, size A80, whatever it is. You look at it, you stare at it long enough, you understand what's going on. Now with these digital models, there is a lot more. So, and this creates the need of having digital approaches of how you actually analyze the data. Now, it could be the usage of AI, it could be Python, but there needs to be a better way to understand the data that lives inside this black box that is a BIM file. So it's very important to do that. And from the other point of view, the improvements that programming languages like Python can bring to the design stage, where you can start thinking about more complex calculations that you can do. I know we are all familiar with Excel. Excel is great, and it's probably like the most used, I don't know if it's probably the most used user interface for engineers.
Yes,
Python,
exactly.
Yeah, Python doesn't give you a user interface out of the box like Excel does. But the power that there is behind programming languages like Python is that you can customize your calculations the way you want, and it could be super powerful. So yeah, that's very interesting. Now let's think about the future. Now the future is unknowable. Nobody can predict that, unless if you can, please. I just want some numbers. But other than that, let's think about the future of the digital engineering industry and how it could change in the next decade. And from your point of view, what are new technologies that will transform digital engineering in the next, let's say, 5 to 10 years?
Yeah, I guess there are lots of them. And the most popular one, I guess everyone is talking about the AI. So there are lots of potentials by using AI, even in the construction and civil engineering. At the moment, I don't think we see too much use case yet. But I think in the future, once we got high quality of the data, there will definitely be many of the AI-driven decision-making things happened. So that's the biggest thing. And the next thing I would say is AR, the augmented reality. I really like this feature. And I think we have some of the team are using this kind of the feature on site already. So it's pretty much what you can do for the construction team is they can overlay the real model, the real digital model to the real world. Like if they want to see, where's this bridge, and they want to compare the construction process with the digital bridge models, they can see that by using AR, which is a very, very powerful tool, I think.
It's incredible how we take for granted certain technologies that were probably impossible to imagine many years ago, and now we just go with a tablet on a construction site and we can overlay reality and virtual on a device. It's incredible that has evolved.
Yeah, I think I really like the overlay features. Like before we talk about the 2D drawing overlay in the 3D model, but that's kind of still in the design or in the digital 3D model, this space. But then now, when it comes to construction, we want to overlay the models with the real construction progress. So that's another layer add on to the 2D, 3D, and then the real world progress.
Yeah, definitely. And we know that one of the challenges of the digital transformation is the adoption. So it's very hard for companies to evolve and adjust and adopt new technologies because, as we said, there's been a fast transformation and it's still happening. So what do you think, what can construction companies do to stay ahead of the adoption at the moment?
Yeah, I think the first one is to have a good culture, which I think that for me, the spirit is to keep curious, keep learning, and keep sharing. So if everyone can kind of follow this kind of spirit, I guess it definitely will do some of the big, benefit for the construction company in the long-term run. And also, I guess for the construction, our own companies, we need to test many of the new digital solutions in the real projects. As I said, the cost probably be the first challenge at the beginning. But once we test them, then we know what they can do, then we can, make a change.
Yeah, definitely. And from the OpenBIM point of view, what's the next big breakthrough in OpenBIM AI in construction that you predict will happen?
Sometimes I was thinking OpenBIM, like in the civil engineering or the construction industry, the data, from my understanding, is not really structural data, right? So we have the drawings, we have reports, we have the models, but how can we convert this kind of unstructured data to a structured data, which the machine, they can be readable for them. That's the biggest challenge. And OpenBIM, the open file format, I guess, is probably a solution. So this means, once we got the different models in the open data format, I think there must be a potential that we can use this kind of the structured data to train our deep learning models. And after that, we can kind of really unlock the AI potentials. We probably can, do some predictive design optimizations, by using AI to analyze the past projects and to understand, to ask them, like what we do for ChatGPT, to just ask some questions to suggest the cost-effective and sustainable way to have a design-efficient solutions. I think that's how we can achieve.
Yeah, that would be incredible. I'm waiting for the moment to happen.
Yes, me too.
Yeah. But thank you very much, Yatong, for today's chat. I think I've learned a lot. I think our audience has learned a lot. We are at the end of our episodes. But before we go, if people want to reach out to you, where can they find you?
Yes, the easiest way would be LinkedIn. If you just search my name, you will find me. And also, I have a personal website that you can find from the LinkedIn as well. And yeah, if you want to have a chat or discuss more topics, just send me the message. I will reply. Yep. Welcome to any of the comments.
Thank you very much. This was great. Thank you.
Thank you. Thank you so much.